The female reproductive system is very complex because it involves the menstrual cycle, pregnancy, and childbirth. There are 4 different hormones in the female reproductive system: FSH, or follicle stimulating hormone, LH, or luteinizing hormone, estrogen, and progesterone. Estrogen and progesterone are produced by the ovaries. FSH and LH are produced by the anterior pituitary gland. FSH brings about the maturation of ovarian follicles, whereas LH is the ovulation hormone. It surges right before ovulation. Estrogen is necessary for maintaining the female characteristics and to grow and develop the endometrium. The progesterone is often called the pregnancy hormone. It maintains the endometrium. Let's divide the female menstrual cycle into 4 weeks. Here's week 1, week 2, week 3, and week 4. It is not to say that all women have 4 weeks. Some are shorter and some are longer cycles. The first day of a woman's period is the first day of the menstrual cycle. During the first week, FSH is released and it picks a single primordial follicle and influences its growth. Here is a secondary follicle, followed by a mature follicle, all growing under the influence of FSH. Once the mature follicle is ready, it still needs one more hormone before ovulation, and that hormone is LH, or the luteinizing hormone. LH surges right before ovulation, and ovulation occurs. The secondary oocyte that's released is picked up by the fimbriae and goes to the fallopian tube and waits for the sperm. The ovarian follicles release large amounts of estrogen, preparing the female reproductive tract for fertilization. Once the ovulation is finished, the empty follicle grows in size and becomes the corpus luteum. The corpus luteum releases progesterone, and the function of progesterone is to maintain the endometrial lining in preparation for implantation, should fertilization and implantation occur. The estrogen grows the endometrium. However, it is the progesterone that grows it even more and maintains it. If fertilization and implantation do not occur, then the corpus luteum becomes corpus albicans. It regresses. As a result, estrogen levels crash, and so do progesterone levels. This brings about the symptoms of the premenstrual syndrome, or PMS. Since there is no more progesterone left, the endometrial lining is eliminated, and it starts the first day of the period and therefore a fresh menstrual cycle. So what happens if fertilization does occur? We just mentioned that the estrogen that is produced by the ovarian follicles prepares the female reproductive tract for sexual intercourse and fertilization. So right around the time of ovulation, the cervical mucus that is produced under the influence of estrogen makes it easier for the sperm to travel. In the meantime, the egg is released and it waits in the fallopian tube. Here's the sperm traveling in through the cervical mucus and reaches the egg. Here is cleavage and development, and the early embryo traveling and getting ready to implant. Once the blastocyst implants in the endometrium, it releases a hormone called HCG, human chorionic gonadotropin, which forms the basis of the pregnancy test. This HCG maintains the corpus luteum, which in turn releases progesterone that maintains the endometrium. Because the corpus luteum stays intact, the endometrium also stays intact, and as a result, there is no period and there is no new menstrual cycle. So what about twins? There are two kinds of twins. Fraternal twins, who are basically siblings that happen to be in the same place at the same time. Identical twins are genetically similar. So how do they come about? So fraternal twins, you have two eggs produced by the mother. Instead of one egg per month, she produces two eggs that month, and two different sperm fertilize the eggs. So one sperm for each egg, and you produce two new embryos. For the identical twin, the mother produces only one egg, and only one sperm fertilizes the egg. The zygote that is formed undergoes cleavage. The first cleavage division produces two cells. Normally, these two cells stay together and continue on through the cleavage process, but in the case of identical twinning, these two cells separate and produce two new embryos.